Reach question 3. So before we start question 3, Marika, you're in the exam and you're done module 1, but just want you to take up your water and you sip some water, all right? You sip your water and you say, nice. You say, all right, come see what I go on now. See what them really I deal with. So now, Marika, boy, what are they doing now? Let's see. It says let A be equal to A1I plus A2J and B be equal to B1I plus B2J with the magnitude of A being 13 and the magnitude of B being 10. Find what is the resultant of vector A plus B times vector A minus B. Oh gosh, them ask this. That's nice. Now this look tough, don't it, Marika?
Yes, sir.
All right, now we're just gonna dissect it nice and easy. Let's start by writing down what they say. All right, anytime it look a little bit challenging, start by writing down what them say. So them tell we say you have some vector A, and them tell we say vector A is equal to A1, A2. Even put it in vector form, make it look easier. Don't this look pretty if you look on? Say A equal A1, A2, A2, right? That look a little easier to look at, right? And then they tell us that vector B is B1, B2, don't it? Right, Marika?
Yes, sir.
So now that they tell us that, let's see what else them tell we. Them tell we the modulus of A is 13 and the modulus of B is 10. So them tell us the modulus of A is equal to 13 and the modulus of B is equal to 10. All right. All right, let's look back. I think that's what them say, 13 and 10, yeah. Then them want us to find, so let's write in black what we need to find. We need to find out what is A plus B dot A minus B, and not even times a dot product. Oh, sweet Lord. Let us tackle this one, is dot product. All right, now Marika, don't worry. They give you two information here. Magnitude is just telling us that the magnitude of A, Marika, remember the magnitude of A would have been A1 square plus A2 square. Would you agree? All square rooted, that's the magnitude of A from this, right? Right,
Yes, sir.
Marika? And that would be equal to 13. So now we can say, okay, if we square both sides, we end up get that A1 square plus A2 square. We'd end up get that is equal to 169 if we squared both sides, don't it? Right, Marika?
Yes.
Nice. Now, if we were to continue right here, so now, and look at this one now, this one is telling us that B1 square plus B2 square, right? They're telling us that that's equal to, by the way, we have to square root it for the magnitude of B. And they're telling us that that is equal to 10, don't it? Right, Marika?
Yes, sir.
So we can write that B1 square plus B2 square, that equal 100, no? Right, Marika? Right? Right, Marika?
Yes, sir.
Nice, but Marika, pre-war go on now. We still don't know what we are doing. But guess what? If you expand out the right-hand side, you can say, why them try to trick me? Let's end up expand out the right-hand side. A times A is A square. But this is the difference of 2 square. Isn't that just A square minus B square? Why are they asking us for the difference of 2 square? The difference of 2 square, that, Marika? A plus B times A minus B. That's the first thing we said today, though. But then, Marika, look at this. We also said today, remember I tell you all this powerful? The modulus of A square is A squared, huh? Right?
Yes.
So then we have the modulus of A square, Marika, minus the modulus of B square. But catch the Marika, the modulus of A is 13. So we can just put this is now 13 square minus the modulus of B at 10. So that's a minus 10 square. So that's just 169 minus 100. 69. Look how they make it seem hard, but it easy. Just tell them, well, easy, soft. Don't it? That never nice. That nice, don't?
Yes, sir.
Them I try trick when they realize, oh God, I saw it easy. Yeah, man, it that easy. Now let's look at the next part now, Marika. They tell us that if 2b minus a equal 11i, find out the possible values of b. They tell us that 2b minus a is 11i. Find out what the possible values of a and b can be, meaning what are the two vectors. You need to find vector a and vector b. Won't finish this question. Whatever we get, I'm going to put it on the geometer sketchpad so you can see that it is true as well. So 2b minus a is 11i. So first thing, Marika, will start with that. Write down what them tell we. 2b minus a equal 11i. So since this is what we have, Marika, you have this right here, so, all right, 2b minus a. Remember, vector b by itself is 2 times, this is just b1, b2, minus vector a. Remember, vector a is a1, a2, don't it? Yeah? Right, Marika?
Yes, sir.
And this is equal to, if you write this side in column vector form, this is really the I part is 11, and you now have no j. So since we now have no j, we put a 0 down here, so down. Right? Right, Marika?
Yes, sir.
So what we end up with is that they're telling us that 2b1 minus a1 is equal to 11. And down here, so we're getting 2b2 minus a2 is equal to 0. If this is what they're telling us, then okay, no problem. This is what they're telling us. This is the two equation. This is the two equation that we need to solve. All right, so we need to solve these two equations to find a1 and b1. Now, Marika, we have to also bear in mind that these are true. We have two more equations to help us. Remember that a1 squared plus a2 squared is 169 and b1 squared plus b2 squared is 100. So I'm going to put that over here. So it's really four equations we have, Marika. Don't look on it and say, oh God, sir, watch it. 1, 2, 3, 4 unknowns and two equations. No, because we have a1 squared plus a2 square equal 169. Don't think we'd have just dash with that one there, so. And then the next one we have was that we had b1 square plus b2 square equal bills. Yeah, man. So now I'm going to do it your way, substitution. I know you prefer it that way. From this one, we're going to make A1 the subject, because if we make A1 the subject from this one, we'd end up realize that A1 is equal to, we can bring over the A1 and bring over the 11 to get A1 is 2B1 minus 11, right, Marika? Right?
Yes, sir.
And then now we can plug this into this equation right here. Let me see. This is A1 is 2B1, so we're going to plug it for B1 in here. Well, we're going to plug it for A1 in here. My apologies. So we're going to end up get that. This is now, oh, and let me make A2 the subject from this one too. And making A2 from this one, I'm going to get A2 is 2B2. That's what I'm getting. A2 is 2B2. So why am I doing this? Because if I plug these two equations, Marika, if I plug A1 here so, and I plug A2 here so, they were nice, were straight. So I'm plug A1 here so now, so A1 We're going to rewrite A1 as 2B1 minus 11. This is being squared plus A2. Now A2 is 2B2 square and it's equal to 169. Now, Marika, we don't like these complex equations, so we're going to expand out the square. First term square, that's going to be 4b1 square minus twice the product of the two, that's minus 44b1 plus the second term square, 11 square is 121. And then we have plus 2b2 square is 4b2 square, and that's equal to 169. So now, Marika, we have 4b1 square and 4b2 square plus 121 minus 44b1 equal 121. So, Marika, look how I'm going to do it. I'm going to group it up this way. 4b1 square plus 4b2 square. You see this 121, may I bring it over here, so, but 169 minus 121, we realize that that'll be, what's 169 minus 121? 169 minus 121. What's 169 minus 121, Marika? No, it's 40 something.
48.
48, nice. Now, Marika, look on this. If we factor out of 4, we're going to left back with b1 square plus b2 squared, huh? Right, Marika?
Yes, sir.
b1 square plus b2 square minus 44b1. Yeah, man, I saw Cape nice, and Cape is so nice. But Marika, guess what? We said that b1 square plus b2 square is 100. So this is 4 times bills, though. Right? 4 times 100 minus 44b1, and that equal to 48. Oh, Marika, you agree with me?
Yes, sir.
Nice. So now we can just go around here. So now and finish. 4 times 100 is 400. So end up get 400 minus 44b1, and that is equal to, I change it from common B to capital B, my mistake, that equal 48. So now we can just solve it. We can bring over the 48 over here. 400 minus 48 is, I think that's 352, and that's 44b1. Is that right, Marika? 400 minus 48 is 352? That's right?
What you said, sir?
400 minus 48.
Yes.
So now we can divide both sides by 44 then. What's 352 divided by 44? That will be B1.
8.
8. Nice. So B1 equal 8. Now, Marika, once we get B1, the question literally done. Because look at this. Now we can find what B2 is. Because if B1 is 8, you're going to end up have 8 square plus B2 square equal 100. Now, Marika, we're going to know that 8 squared is 64. The only number this can be is 6, because 8 squared plus 6 squared is 100. All right, so after a whole heap of practice, you'll be able to just look at them and tell. But for now, you know, you'd have to transpose and make B2 the subject. But we can look at it and then tell them, say, B2 equals 6. Because we know 8 squared plus 6 squared, that's how we get 100. Now remember, since we know B1 and B2, we can also now find A1, because now that's going to tell us that A1 is now going to be equal to, B1 is 8. 2 times 8 is 16. 16 minus 11. 16 minus 11 is 5. Then here, so now we're going to have A2 is 2 times B2. 2 times B2, and B2 was 6. 2 times 6 is 12. So we're done, Marika. We're nice. So now, you're not finish yet, you know, you need to tell them your answer. We're going to tell them, say, vector A is equal to, write it in the IJ form how they give it, Marika. You have to tell them that vector A is A1. A1 we find out was 5. So it's 5I plus 12J. That's vector A. Then we can give them vector B now. Vector B is just 8I plus 6J, right? Right, Marika?
Yes, sir.
Nice. Now, just because I want to verify to you that everything is correct, right? I want to verify that everything for you is correct. I'm going to open the geometer sketchpad and show you the graph and show you so everything makes sense what we do. This is the beauty of connecting vectors and geometry with this right here. So we're going to connect them. Can you see the graph? Can you see the graph, Marika?
Yes, sir.
All right, so I'm going to plot the points. We said it was 5, 12. 5, 12, that was vector A. And then vector B was 8, 6. All right. So I'm just going to show you now. This is vector A right here. So I'm going to label this point as A. And then I'm going to label this point as B. All right. And look at this now. I'm going to actually measure the length of vector OA. I'm going to measure it. Remember, they said that OA, they said it was 13. So if I measure it, we're supposed to get 13. So I'm going to go to measure distance. Box cover, Marika, look how we get 13. I never 13 was the length, though. Right? And then vector B, remember, so it's supposed to get 10. If we measure vector B, you see it there? We'll get with 10. Yeah, man. So she said them they have to be with A there and with B there, don't? You saw them nice? That not nice. This question did nice, don't Marika? Get 69 here, so. And right here, so we can tell them, so we end up get A did equal to 5I plus 12J. And we did end up get B equal to 8I plus 6J. Them nice, see? Nice, right? Pull it this, Marika?
Yes.
Nice. So that take care of the vector part. Nothing really to it. It only look like it did have a add, but it never add. Right. So now the next part, they tell us that the line x minus y plus 1 and the circle has this equation. It says the line passes through the center of C. So it says, oh no, we're supposed to show that the line passed through the center of C. Now, Marika, if the line passed through the center of the circle, in order to show that the line passed through the center of the circle, you don't need to solve it simultaneously. What you can do is that show that the center of the circle satisfies the equation of the line. What you can do is show that the center of the circle satisfies the equation of the line. So this is what they give us. This is part 2 now. They give us the circle x squared plus y squared, x squared plus y squared, minus 2y minus 15 equals 0. Minus 2y minus 15 equals 0. They give us this. Now, Marika, if they give you this, what you can do is realize that you're not an x here, so this is just x squared plus, complete the square for the y terms, it's y. Remember how complete squares, Marika? You divide the 2y by 2 to get minus 1y, but you're only going to put the 1, close the bracket, square, and then subtract 1 square. Minus 15 equals 0. That's how we complete the square. So what we end up get for the circle is x squared plus, this is now y minus 1 square Then minus 1 minus 15 is 16, but bringing over the 16 over here, we're going to get equal 16, and I'm going to write 16 as 4 squared. So what that means is, Marika, the center of the circle, the center is 0, because we're not on x minus nothing, so that's 0, 1, right? The center of the circle is 0, 1. So now what we're going to tell them is, if the line L passes through the center, if the line L passes through the center, then L, then the point 0, 1 lies on the line. So this is what we need to show. We just need to show that the center lies on the line. So we're going to plug it into the equation of the line. But remember, what was the line? X minus y plus 1 equals 0. So the line is x minus y plus 1 equals 0. So now, Marika, we're going to plug in x as 0. So plugging in x as 0, we'll get 0 minus 1 plus 1. That equals 0 for true. And so the equation is satisfied. The equation is satisfied, so hence the center lies on the line. That makes sense, Marika? It makes sense? Right, Marika? We'll call it this?
Yes, sir.
Nice. So nothing new, nothing major. We'd have done something similar to our IA as well to show a point lies on the circle, so no problem. Now it says, Marika, the line intersect the circle at P and Q. Determine the coordinates of P and Q. So now if the line touches the circle at P and Q, I'm just going to sketch the circle. This is a circle, something like this. The line is y equal x plus 1, and it passed through the center. So this is the line, and the center of the circle are this. The center of the circle is 0, 1, right? So we need to determine the coordinates of P and Q. Now, Marika, you're thinking simultaneous equation for find P, don't? P and Q, don't? Right, Marika?
Yes, sir.
No, there's another way you could do it. You could realize that the radius is 4, and so the distance from P to the center is 4, and the distance from here to also 4. So if this distance is 4, Marika, then what that means is the change in y over the change in, if you were to actually look at it this way and say that, all right, this right here so is P, all right? What we're saying then is the change in x are going to be the same and the change in y are going to be the same. So once we find one point, we can easily find the other. So don't necessarily have to do simultaneous, but let's do simultaneous, then do it the other way. So let's do simultaneous first. So we have the line x minus y plus 1 equals 0. So I'm going to write it as y equal to x plus 1. All I do is make y the subject, so I can plug y in the circle here. So now what we're going to get is x squared plus, replace y with x plus 1. So that is now x plus 1 square. They will subtract 2 times x plus 1, and they will minus 15, and that going to equal to 0. All right, no problem. So now we're going to expand this now. So now we're going to get x squared plus, it's going to become x squared plus 2x plus 1. And then now we're multiplying the minus 2. This is going to be minus 2x minus 2 minus 15. And this is equal to 0. So what we're going to end up getting now is this x squared plus this x squared is 2x squared. Then 2x minus 2x, that's 0. Then 1 minus 2 minus 15. Let's simplify this. 1 minus 2 is 1. Minus 2 is minus 1. Minus 1 minus 15 is minus 16. So that will tell us that 2x squared equals 16. Divide through by 2. So x squared is equal to, that's 8. So then now we can say x is equal to plus or minus the square root of 8. That is x. But then now remember what is y. Y now, Marika, y is x plus 1. So that means the y value now going to be plus or minus the square root of 8 plus 1. All right, so how do we write this pretty? To write it pretty now, we need to write it as coordinates. So we're going to tell them, say P is the point, Marika. P is the point. The square root of 8 can be simplified as 2 root 2. So P is 2 root 2, comma, the y value would be 2 root 2 plus 1. 2 root 2 plus 1. Close that bracket. Then the next point, Marika, Q, is going to be the minus of it now, which is minus 2 root 2, comma, minus 2 root 2 plus 1. You never have to write minus 2 root 2. You could have just write root 8. If you want to stick with the root 8, you could just write root 8. All right? Cool with this, Marika?
Yes, sir.
All right, so just to write it back around here, you could tell them, you find the 2 points, then P is one of the point of intersection, them are root 8, comma, root 8 plus 1. And then this would be now Q, and Q would be minus root 8 minus root 8 plus 1. And that's it. Nice and easy, soft. Now, since this is what we have now, all right, since this is what we have for P and Q, it says find the constants A, B, and C such that X is this, Y is this, and these are parametric equations of C. So find the constants A and B and C such that X equals B plus A cos theta and Y equals C plus A sin theta are parametric equations in the parameter of C. All right, so we need to work this out now. So if we're going to be doing this now, all right, I hope it give me the theta properly. All right, give me the theta properly. So find the constant A, B, and C such that these are parametric equations. Numerical parametric is so nice. All we have to do is make cos theta the subject, so we can say X minus B over A. If we transpose, that would be cos theta, don't it? Yeah, that would be cos theta, right?
Yes, sir.
And then right here, so now if we transpose, we're going to get Y minus C over A, that's sine theta. But we know say sine square theta plus cos square theta equal 1. When you write that big on the paper, if you can't write it big on the paper, then give a parametric like this, or you put a box around it. So you put sine square theta plus cos square theta is equal to 1. Put a box around it, make them say you know what go on. Yeah man, make them say you know what go on. So then now you can just take some books and change sine squared, then is going to be Y minus C over A. That's sine theta, but you need to square it, plus this is then going to be X minus B over A all square, and that is equal to 1. Now if you want to pretty it up, you can square the numerator to write Y minus C square over A square plus, this is going to end up being now X minus B square over A square. You're going to end up get that this is equal to 1. So what do we do now? We multiply through by a square. If we multiply through by a square, what we're going to end up get is y minus c square plus.
Sir, could you give me 5 minutes?
All right, let us finish this one. Then you get the 5 minutes. All right, let's finish off this. So just multiply through by a square, y minus c square plus x minus b square equal a square. All right, you cool with this?
Yes, sir.
All right, you can take the 5 minutes now.
Yes, I'm back.
All right. All right. So let's finish off this now. It says you have one other circle, C2, and it says it have the same radius as C, and it touches L at center C. Find the possible equations of C2. Now, Marika, that might be a little bit difficult to dissect, so let's break it down small. It says you have one other circle, C2, that have the same radius as C. So the first thing is we can state a boom, and we can draw a circle. This is the circle C2, all right? We know that the circle C2 have the same radius as C. So let's label this that this circle is C2. And we know so the radius of C2, we know so the radius is equal to the same as the radius of C. The radius of C, remember, was 4. So the radius of C2 is also 4. Now what they tell us, Marika, is that C2, them tell we say, it touches L at the center of C. So if you were to draw the line L and this other circle C, so you have the next circle C, Marika. Let me show you. Let's say another circle C was, I want to make it be the same size because they must be the same size because that's how they'll have same radius. So this is the next circle C, something like this. Just want to move it over now. This is the next circle C. Them touch. It touched the circle here at the center. All right. It touched the circle here at its center. Because they're telling us that this can be the center of C. This one right here so is C. And then this is the line L. So this is a possibility, right? Not exact, but this is a possibility of what is happening. All right. But we know the center of C. The center of C was, I think, 0, 1. It was center of C is 0, 1. So they're giving us a point on the circle, Marika. They tell us that this is 0, 1. All right. So we have a point on the circle. And we know the radius of the circle, right? The radius of the circle is 4, right? So we need to find the possible equations of C2. So we can call the center of this circle AB for now, right, Marika? You find if we call it AB?
Yes, sir.
So we need to find this circle C2. Now, Marika, if the radius is 4, and we know that this right here says the radius, then we're not good, Marika. We can set up equation. We can tell them, say, see it here. We know say A square. We know say, sorry, not A square. We know say x2 minus x1. In this case, A square minus 0 square. We know say A square, not, I keep writing square, A minus 0 square. We know say this square minus in bracket, this is now B minus 1 square. We know say this must equal to, well, the square root of this is supposed to equal to 4. Right, Marika? That's distance of a line formula, right?
Yes, it is.
So now we can end up just this and say, boom, that means the A square plus, it should be a plus, that means the A square plus B minus 1 all square, it's supposed to equal 16. It's supposed to equal 16. So now, Marika, we need to now find out what are possible values, what are possible equations, what are possible numbers that A and B can be, such that this can give me 16. So for example, Marika, let's say I was, let's say I am crazy enough to put that A is, I don't know, let's say root 8. Let A be equal to root 8. You might say, why root 8? If I put A as root 8, Marika, that would tell me let root 8 be equal to A. Root 8 squared would be 8. So that would then tell me say 8 plus, this would then be B minus 1 square is equal to 16. And so if I were to find what is B, Marika, I'd end up get B minus 1 is equal to, let me see, I square both sides, I'd get the square root of 16 is 4, but it would be, wait, first, I'm sorry, I bring over the 8, so b minus 1 square would be 8, and then I square root both sides to get b minus 1 is equal to the square root of 8, and when I square root I get plus or minus, so that means that the possible values of b, Marika, is plus or minus root 8 plus 1. So what does that mean for us, Marika? That means that we get the equations of the circle then, Marika. So that means the possible equations of the circle then. So the possible equations them are, we're going to write it right here. So possible equations. Possible equations of this circle is going to be x minus the x value at the center. So it would be x minus root 8, x minus root 8 square plus, this is now plus y minus this right here, y minus root 8 plus 1. Put a bracket around the root 8 plus 1 square equals 16. This is one possible equation. Another possible equation, Marika, is what about when b is minus? So the x stay the same, and so our next possible equation is x minus root 8, close that bracket, square, plus, in bracket, y minus in bracket, it would be minus root 8 plus 1, close the bracket, all square equal to 16. These are the possible answers. Cool with this?
Yes.
Now, I could verify for you on the Geometer Sketchpad, say so log one, say so that it verified, but should kind of getting later. We want to finish the paper. So we're just gonna move along, all right? All right. That would be question 3 there. All right, so cool with question 3, by the way, Marika? Cool with it?
Yes, sir.
All right. Now we need to look at question 4. Question 4 start out nice. It give you one equation to solve. We love to solve equation. Where's someone quadratic? By using x equal cos squared theta, find all values of the angle theta. So first thing, Marika, I'm gonna do is not write down the question. I'm gonna clear all of these screen so that I have space for us to do the rest of the questions. So let me clear all of these. Clearing all of these. Clear all of these. Clear. 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 All right, so now we're going to start now, Marika. Now we're going to start. It says by using x equal cos squared theta or otherwise, solve this easy equation. 8 cos to the 4 minus 10 cos cubed plus 3. So we need to solve, Marika, 8 cos square, well, not cos square, cos to the 4 of theta minus 10 cos square theta plus 3 equals 0. Minus 10 cos square theta plus 3 equal to 0. All right, this is what we need to solve. If this is what we need to solve, first thing we need to do is do what them said. Them say call x cos square theta. If you call x cos square theta, Marika, if this is x, then we know say x square is cos to the 4, don't it? X squared cos to the 4, don't? That makes sense? This makes
Yes.
sense, Marika? Yeah, man. So that means we can rewrite this equation as 8 times cos to the 4 is x squared. That's 8x squared minus 10 times, this is cos squared, so that's just x plus 3 equals 0. Look how it look nice now. I just want quadratic this. That's too easy. We'll just factorize like a grade 9 stuff. Signs are the same, both of them negative, so it's 3 and 1 minus and minus. Now we need it to be 10, so if we go so now, we're gonna have to be very careful with which two number we use. Let's see if we use 2x and 4x, what would happen? Yes, that would work out. If I put 2x here, 2x and put the 4x here, then this would be fine. This would be 8x squared minus 6x minus 10x plus 3. So in a case like this now, Marika, we end up solving 2x minus 1 equals 0. So we're solving x equal to a half, right?
Yes, sir.
And over here, we're solving x equal to 3/4, right? Right, Marika?
Yes.
But x is cos squared theta. Since x is cos squared theta, we can write it down that we're solving cos squared theta equal to a half. That's all. We're solving cos squared theta equal to a half. So we can take the square root of both sides, Marika. And so we're solving that cos theta is equal to the square root of a half. And when you square root, you know you get plus or minus. Yeah, man. So that's one possibility. And over here, so now if we square root this now, we'd end up be solving cos theta equal to the square root of 3 over 4. The square root of 3 over 4. Now, Marika, this is where it gets nice. So what we're solving is, let's look at this part first. Cos theta equal the square root of a half. Square root of a half, Marika, is root 2 over 2. Yeah, you agree with me, though? Square root of a half is root 2 over 2, though? Right, Marika?
Yes, sir.
So draw a circle and know so when we square root, we get plus or minus. So because we get plus or minus, Marika, we want every quadrant. We want every quadrant answer. We want we cos negative and cos positive. But Marika, them tell us so them only want the answer between 0 and pi, 0 and 180 degrees. So what that means is, Marika, we can say, so oops, we can dash for the third quadrant and dash for the fourth quadrant. Because we only want the top half of the circle. So what we need to do then is take cos inverse of root 2 over 2. Cos inverse of root 2 over 2, Marika, I want you to remember this, right? That cos inverse of root 2 over 2 is pi by 4. These are known as exact values. It's important if you remember them, especially for a paper one, right? This is pi by 4. So what we end up get, Marika, is if the angle in this quadrant is pi by 4, we can end up say theta is equal to pi by 4, or the next answer right here, so it's theta equal pi minus pi by 4. That's for the angle in this quadrant right here, pi minus pi by 4. Right, and pi minus pi by 4 is 3 pi by 4. Are you done? 3 pi by 4. Now, Marika, down here, so now we're going to be solving the cos of theta is equal to the square root of 3 over 4 is, what's the square root of 3 over 4? For some reason, that one slipped me. Square root of 3 over 4. Square root of 3 over 4. That's root 3 over 2. Come on, man, I'm disappointed in myself. That's root 3 over 2. You should have remembered that one. That's root 3 over 2, but it's plus or minus. So now, Marika, we draw a circle, but we only want the first two quadrants. We want up here and up here. So since these two we want, what we're going to end up get, Marika, is theta is equal to, we take cos inverse of root 3 over 2. By taking cos inverse of root 3 over 2, cos inverse of root 3 over 2 is cos of what give root 3 over 2? That is, I think that's 30 degrees, but I'm not so certain, so I'm just going to check it out. Cos inverse of root 3 over 2, I think it's 30. Yeah, it's 30, it's pi by 6. I didn't fully remember it, but it's pi by 6, so that is pi by 6. Then the next answer would be pi minus pi by 6. Pi minus pi by 6. But pi minus pi by 6 is 5 pi by 6. 5 pi by 6. So, Marika, in conclusion, we can tell them our 4 answers now. We can tell them, so the first one is pi by 4. So up here, so just write out all of the answer them. We have pi by 6, comma, we have pi by 4. We have, next answer is, think 3 pi by 4, and we have 5 pi by 6. Those are the answers. You cool with this, Marika? Cool with this?
Yes, sir.
Nice. So this is this right here. All right. Now the next part now, Marika, it gives us, the diagram below is not drawn to scale. It shows a rectangle PQRS, and it's inscribed into another rectangle. So then just put a rectangle in a rectangle. And then let's see what they want now. So let's zoom it down a little bit. Let's say the angle that SR makes with DC is theta. Find in terms of theta the length of the side BC. We need to find the length of the side BC. Okay, let's see what we need to find right here. So I'm just going to use a red line for BC. This is BC, Marika. Agreed? That is BC, though? Right, Marika? This is BC, though? The whole of this, right?
Yes, sir.
Now, Marika, let's break it down in terms of triangles. In terms of triangles, Marika, it's clear that we can see that BC is equal to BR plus RC, though? From B to R plus from R to C, that's BC, though? Right, Marika? We call it this? BC is BR plus RC?
Yes.
Now, Marika, look at this now. We're going to focus on this triangle. In this triangle, you have the hypotenuse and you have the angle. First thing, and then you want RC. So you can call RC X, that's sine theta. So what we do now, Marika, is that the sine of theta is opposite, which is RC, over the hypotenuse of 8. So if we cross multiply, we see that R times C is 8 times the sine of theta, don't it? That makes sense? RC is 8 times the sine of theta. Right, Marika? Right, Marika?
Yes, sir.
Nice. Now, we need to find the length of BR. Let's analyze how we're going to find the length of BR. All right. Now, let's see. We need an expression for BR. Now, we know this. We know that this is where you have to know properties of. We know that this side is parallel to this side. All right. And we know that this side is parallel to this side. That's just how these things behave. We already know that this angle is 90 degrees. All right. We're trying to use some Z angle. So we need an angle in this triangle, Marika. Okay. We cannot find out what any of these sides are until we get an angle in this triangle. We know this angle is 90. All right. Now we know this angle is theta. We know this angle is 90. We know this angle then is 90 minus theta, right? This angle is 90, right? Minus theta, don't it?
Yes, sir.
Right? And if this angle is 90 minus theta, Marika, and this angle is 90, then the angle here must be theta. That makes sense? This angle of theta?
This makes sense.
So now we get an angle in this triangle. And so since we have this angle, Marika, now we know that we need to find BR, but BR in this triangle is the adjacent. So we can tell them now, say, the cosine of theta, Marika, is going to be equal to the adjacent, which is BR or RB, however you want to write it, over the hypotenuse of 6 in this triangle. All right, in this triangle that we shade over in black, we have theta, we have the hypotenuse, and we have the adjacent being BR. So transposing, we'll get BR or RB is 6 times the cos of theta. So now we're nice, Marika, cause now that we know RC and we know RB, now we can answer them question and we can tell them, say, what kind of easy question this? Now we can tell them, say, BC is equal to BR, which is 6 cos theta. I'm just going to have to write it. It is 6 cos theta, 6 cos theta. Then it is now plus RC, which is 8 sine theta. This is 8, by the way, plus 8 sine theta. So it's 6 cos theta plus 8 sine theta. Just 2 marks, that should be 3. Okay, no problem. Now, Marika, let's see what they ask for next. They say, find the possible values of theta if BC equals 7. Now, Marika, if BC is equal to 7, remember we have the formula for BC now. We know say BC is equal to 6 cos theta plus 8 sine theta. And now 6 cos theta plus 8 sine theta, that's BC. And now, Marika, we want that the magnitude of BC, which would be the magnitude of 6 cos theta plus 8 sine theta, solve that equals 7, though. That's all we need to do, though. Right, Marika? Right? So we need to solve it to find theta, right, Marika?
Yes, sir.
So now if this is what we're going to do, now, Marika, first thing we need to do is realize we need to put this in the R cos R sine form. We can't solve it like this. We're not crazy. First thing we need to do is find out what is R. R is A squared plus B squared. You saw them I try for subtly trick we, but we well aware of them thing. Yeah. R is A squared plus B squared. Them I try for subtly trick we. If we want to think about the R cos form, so now by doing this, we get R equal 10. Then we can find alpha by saying that alpha is tan inverse of B over A. Tan inverse of 8 over 6. I can't forget this in America. R and alpha. Tan inverse of 8 over 6. We can just put that in our calculator. Tan inverse 8 over 6. Tan inverse 8 over 6. Put that in our calculator. We get 53 degrees, but we want it in well, let's keep them in degrees still. It not really. It don't make a difference if we keep it in degrees. So alpha is 53.1 degrees. So since this is alpha now, Marika, we can write this now in the R cos form. We can end up right. So this is now R, which is 10 times the cosine of, in bracket, theta minus 53.1 degrees, and that is equal to 7. So now we can divide through by 10 to get the cosine of, in bracket, theta minus 53.1 degrees, and that's equal to 7 over 10. That's what we have. And so now, since the cos of this is 7 over 10, Marika, now we can take cos inverse to find theta. So we're going to end up have theta minus 53.1 degrees is equal to 7 over 10. So add the 53.1 degrees to both sides. So we're going to end up if theta is Add that now, 7 over 10 plus 53.1. So add that plus 7 over 10. I think I need to put this in radians. I think in radians would have given me a more accurate answer. Yeah, we're gonna have to put this in radians because then it won't match up. Put this in radians, 53.1. I'm just gonna change this to radians. 53.1 in radians. 53.1 degrees in radians. Or change the calculator mode. Why is not in radians? Mode, radians. Tan inverse 8 over 6, 0.927. Then I add that to 0.7. So it's 1.627. That's it in radians. Theta is 1.627 in radians. 1.627. That's the angle that theta would make. Theta in this case was 0.927 in radians. So that's the angle. Now always remember, if you want to convert it back to degrees, then you have to tell them that, remember, pi radians is 180 degrees. So to convert 1.627 to degrees, now you can call it x. So then now you'd end up tell them x is equal to 1.627 times 180 divided by pi, right? So you have to do these arcos in radians and then convert it back to degrees if you want your final answer in degrees. So we're just gonna plug this in our calculator one last time. This times 180, now we will divide it by pi. That's our answer, Marika, 93.2. So this time tells us x equal 93.2 degrees. 93.2 degrees. Now, Marika, just for show you say it makes sense, right? Look what I'm gonna do. Just for show you say it makes sense, all right? I'm gonna pop out the calculator, all right? And I'm gonna put back my calculator in degrees. And I'm gonna put in 6 cos this, 6 times the cosine of the answer we'll just get, plus 8 times the sine of the answer we'll just get. I was supposed to get that the length height of 7 now. We get 7.64 something, because we'll do some rounding off whenever to, you know, we need to get it more spot on, but yeah. Yeah, so should I round off a little bit better? That's why I always try to say 3 significant figures. So instead of saying 93.2 is 3 sig fig. Guess in a case like this, we need 4 sig fig feet more accurate. But yeah, 93.2, that's x. All right. So that's the angle. Cool it this, Marika? So in this case, theta is 93.2 degrees. Cool?
Yes.
Now, Marika, straight away, is 15 possible? Just by looking at BC. BC is 6 cos theta plus 8 sin theta. Is the length of BC possible to be 15? Is it possible for BC to be 15? I'm going to let you see BC, right? This right here is America. This side of 8, all right, in this rectangle. Can the length here in any possible way be 15? This side, can all of this side be 15? Is it possible for that length to be 15? Marika, think about it. If this hypotenuse is 6, look at this. Let me show you something. If this hypotenuse is 6, right? If you just straighten out the line there, right? I'm going to take this line and straighten it out. That is 6. And if you have this line, where 8 centimeter, right? This line at 8 centimeter, I'm going to take it and straighten it out. If you put them two lines together, can BC ever be 15, Marika? 8 and 6 are 14. See how 14 the long part diagram? Can BC ever be 15, Marika?
No, sir.
No, BC can't ever be 15. Like OBC, or if you add up the OBC, which is the sum of the adjacent of one triangle and the opposite, or if it's bigger than the sum of the two hypotenuse. That makes sense? When the hypotenuse them are the biggest side, that makes sense?
No.
No, but that's not the reason why you would tell them. That's just by looking at it, you'd know that BC can't be 15. But this is going to be the reason now. Now, Marika, first thing we're going to tell them is BC is equal to, remember, R, which is 8 times the cosine of theta minus alpha, which is theta minus 53.1. Now, Marika, we remember them thing I said the maximum value is 10. In this case, we can say that the max BC can be is R. Didn't we learn that? That the maximum it can always be, when it's in the R cos form is R. So in this case, BC maximum length is 10 centimeter. Isn't that so, Marika? BC maximum length is 10 centimeter. That makes sense? So 15 not possible. That makes sense, Marika? This makes sense?
Yes.
Because the cost graph can't pass this. Cool. Now I just want to verify something again. Remember, we end up so that the angle was 93. 93, that can't be bigger than 90. Because remember, it's a rectangle. And then the triangle in the rectangle, it can't be bigger than 90. So what we have to do is we have to actually correct the decimal placings. Because if we put 93.2, that would be wrong. So we're just going to fix it up. Going back here, let me see. Put it in the RCOS form. We divide through by the 10, that's 0.7. We change this to tan inverse of 8 over 6. Let me check that one more time. In radians, tan inverse 8 over 6. That's 0.927. And then we added that to 0.927. We added that to 0.7 because we need to find theta. Ah, see the mistake, Marika, you didn't stop me. I can't believe it, Marika, you didn't stop me. Here's the mistake. When we reach this part, Marika, let me take this off. All right, you can stop me and say, sir, what you do right there? That was crazy. You don't say I throw away the cosine. I throw away the cosine and I'm solving theta minus 0.92 is this. No, I can't throw away the cosine like that, Marika. That means that the cos, that means that theta minus 53.1 is cos inverse 7 over 10. That's the only way we could get rid of the cos, no? Right, Marika?
Yes, sir.
Cos inverse, don't let me do that, man. Cos inverse 7 over 10. And then we could bring over the 0.927 or the 53.1, whichever you're working with. So it would be cos inverse of 7 over 10 plus a 53.1 degrees. Cos inverse 7 over 10 plus 53.1. That's what we do. Then we get our answer in degrees. So now we can put our calculator in degrees. Cos inverse 7 over 10 plus, what was that, 53.1. We check that out. 98.67. They're still giving us It's bigger than 90, so I guess that is it. We add it, bring it over to 53.1, that's just 98.7. All right, but that was off right there. Oh, I just dashed with the cost. I just threw with the cost, so that was crazy. So we have to fix this, tell him it was 98.7. All right, that would be the angle. All right. Now, Marika, it says is 15 part. Oh, do that part already. 15 is not possible. I'll tell him so the maximum value BC can be is 10. Good. So not possible. All right, nice. So now we're at proving some identities. All right, now this one says, Marika, we need to show that 1 minus cos 2 theta over sine, 1 minus cos 2 theta over sine 2 theta is tan theta. And then we just had to be a cost proof. Well, that's crazy. Why am I giving so much cost proof? Let's see what they're doing, Marika. Let's find out what we're doing. You still sexy, wicked? Now, Marika, I'm going to say, look at this. Basically, if you can't prove this, you can't prove this, you can't prove this, then you can't do this. You see that? That's crazy, don't?
Yes.
Because they're literally the same thing they're asking over and over. Why would they do this? All right, that's what they do. Literally, they're saying if you don't know the first one, you don't know the second one. You don't. Literally, that's 13 marks gone if somebody don't know to prove just one of them. So we need to show that 1 minus cos 2 theta over sine 2 theta is tan theta. This would have been in your IA. All right, so nice. Of course, we'd have to break up cos 2 theta as 2 cos square theta. This is 2 cos square theta minus 1. And we know that sine 2 theta is going to be 2 sine theta cos theta. All right, so this was where I got your question from in the IE in module 2. So this is our left-hand side. As we expand it, and by expanding it, what we're going to get now is 1 minus minus 1. So the minus and the minus become, let me see, cos 2 theta is 2 cos square theta minus 1. So what we end up realizing is this minus 1 and this minus 1 become plus 1. So we get 2 plus 2 cos square theta. Right? So we have 2 plus 2 cos square theta over 2 sine theta cos theta. Right? So cool. Let me see. All right, just want to make sure I didn't punch in anything. All right, now what we can do is substitute cos square theta as 1 minus sine square, right, Marika? So this is 2 plus 2 times in bracket 1 minus sine square theta over 2 sine theta cos theta, right? Over 2 sine theta cos theta. Right, Marika?
Yes, sir.
So now what we're gonna do now is realize if we expand out the bracket, our left-hand side gonna be 2 plus 2 times 1 is 2. All right, 2 plus 2. So that is gonna be, something is off. This should have canceled out. Let me see if I wrote this down properly. Going back here, it's 1 minus cos 2 theta. 1 minus cos 2 theta. All right, something is off here. So what I'm gonna do is clear this. I'm gonna clear this. I'm gonna start with the sine identity just to see if it smooths out a little bit better. So I'm gonna start by, instead of using the cos one in the numerator, I'm gonna use the sine. The sine identity is 1 minus 2 sine squared. that would eliminate that part. So we're going to start with 1 minus 2 sine square theta. By doing that now, 1 minus 1 that gone, minus and minus become plus, so we get 2 sine square theta over 2 sine theta cos theta. 2 sine theta cos theta. Now, as we realize, Marika, this 2 right there, so this 2 cancel this 2, and then sine square, the square here and cancel out one of the sine theta. So left back with sine over cos, which is tan, right? Pull it this. Nice. So that's the first part right there. So prove it. So this, nice. So prove of this one. Then them say hence, all them do is replace 2 theta now with 4 theta. So now we're just gonna do the same thing again, Marika, but replace 2 theta with 4 theta. So that's exactly what I was saying was if you can't prove one, then imagine, that's crazy. So now we need to prove this one, 1 minus cos 4 theta over sine 4 theta, that is now tan 2 theta. This is now tan 2 theta, right? Right, Mariko? So now we need to prove this. So again, we're going to start with our left-hand side. Starting with our left-hand side, what we're going to get is this is going to become, doing the same thing, it's going to be 1 minus in bracket. Cos 4 theta, Marika, is 1 minus 2 sine square 2 theta. And then this is divided by sine 4 theta, Marika, is 2 sine 2 theta cos 2 theta. So now the 1 minus 1 gone. So end up just get 2 sine square theta. We get 2 sine square 2 theta being divided by 2 sine 2 theta cos 2 theta. 2 sine 2 theta times cos 2 theta. So now what we realize then is that this 2 cancels this 2. The square cancel out one of these, so we get sine 2 theta over cos 2 theta, which is tan 2 theta. We call it this? Call it this, Marika?
Yes,
It's the
sir.
same thing. It's the same thing we virtually do. And then we're going to do the same thing one more time, but now replace it with 4 theta to 6 theta. Now, that is really sad that they do that because, as I said, if you couldn't prove this one, it's the same thing you do here and the same thing you do here. So that's really sad that they do that. That's really sad. That's too continuous. So, this is now 1 minus the cosine of 6 theta over sine 6 theta. We need to prove that this is tan 3 theta. All right, so we need to prove that this is tan 3 theta. So to prove this is tan 3 theta, we're gonna of course start with our left-hand side. So our left-hand side is equal to left-hand side 1 minus cos 6 theta, but cos 6 theta can be broken up as 1 minus 2 times sine squared 3 theta. Sine squared 3 theta over sine 6 theta can be broken up as 2 sine 6 theta, 2 sine 3 theta, sorry, times the cos of 3 theta. Then the 1 minus 1 cancel, and then the minus and the minus become plus. So we're going to get 2 sine squared 3 theta, 2 sine squared 3 theta over 2 times the sine of 3 theta times the cos of 3 theta. 2 times the sine of 3 theta times the cos of 3 theta. And so what happens now is that the 2 cancels the 2, the sine square, this square, cancel out this, so get sine 3 theta over cos 3 theta, which is tan 3 theta. Now, Marika, I just want to make a generalized conclusion. What we notice is that this is a general conclusion that probably is going to help us with the next part. So this is an observation, just writing this down, an observation. Realize that if you put n right here, so for any number right here, so 1 minus the cos of n theta, or let me put 2n theta here, so 1 minus the cos of 2n theta over the sine of 2n theta, that's just the tan of n theta. Do you observe that as well, Marika? That's just the tan of n theta. You see that observation? This makes sense?
Yes.
So this is going to come in very handy in the next part. All right, so let's look at the next part now and see what I'll go on. So the next part now, it says, using the results in CI and II, evaluate the tan of r theta sine 2 theta plus the cos of 2r theta. Whoa. So now, let's branch off around here. We need to evaluate the sum from r equal 1. Need to evaluate the sum from r equal 1 to n of, writing that down again, tan r theta sine 2r theta, tan r theta sine 2r theta plus the cos of 2r theta. The cos of 2r theta. And don't tell me we're summing from 1 to n. If they say summing from 1 to n, let's see. Yes, we're summing from 1 to n. So let's work this out, Marika. Now, the first thing I observe is if we were to cross multiply this right here, so what you'd end up get is 1 minus the cosine of 2n theta. If you cross multiply it, 1 minus the cos of 2n theta is equal to tan n theta times sine n theta, don't it? Times sine n theta, right? Times sine 2n theta. Right, Marika?
Yes, sir.
And so if we were to bring over the cos 2n theta, we'd end up get 1 is equal to the cosine of 2n theta plus the tan of n theta times the sine of 2n theta. So what am I trying to say, Marika? If you replace n with the letter r, just replace n with the letter r. If you replace n with the letter r, the same thing, Marika, all of this just equal to 1. Yeah, man, so what we're trying to say, all of this here, so equal 1. So this is just the sum from r equal 1 to n of that is 1. And the sum from 1 to n of 1, you're just adding 1 n times. So the answer just n. That nice, though. Answer just n. That nice, though. Right?
Yes.
So cool with this? Nice. So the answer is just n. All right? So this works out to just be n. All right? Cool with this? Cool with this, Marika? All right. So now we have the last